Okay, glycolysis. So glycolysis is a 10 reaction series. Okay. So let's marker here, not that marker. Glycolysis. Going from glucose to pyruvate. Okay. So begin. So I'm gonna do it for you maybe 4 reactions at a time, just so it can fit on the board. So we're gonna begin with glucose. So this is glucose. So this is how we represent it. It's a 6-carbon molecule, number 1, 2, 1, 2, 3, 4, 5, 6 carbon molecules. That's glucose. So glucose is absorbed from the blood, brought into the cells, and then right away the cells will convert glucose into glucose 6-phosphate, meaning the cells will add a phosphate group to the number 6 carbon. That's number 6 one. So now it's called glucose 6-phosphate. Okay. That's reaction 1. And what happens here is that the phosphate that you got to put on here came from ATP. So here, ATP is consumed, broken down to form ADP plus PI, and the PI is what goes here, okay? And the enzyme that makes this happen is called hexokinase. So reaction 1 is catalyzed by hexokinase. It involves taking ATP, breaking it down to ADP and PI, and using that PI to attach to glucose, meaning you phosphorylate glucose. And now once glucose is tagged like this, it can no longer leave the cell. So now it's trapped in the cell by being phosphorylated. Then in reaction 2, we will convert this glucose into fructose, one of its isomers. Okay, so in reaction 2, you convert glucose to fructose, and now so now you're gonna make instead of having 5 carbons in the ring, you'll have 4 in the ring instead. You can push one out here, and still here you have the phosphate groups there. So now you have number 1, 2, 3, 4, 5, 6 carbons there still. Okay. So now this is called fructose 6-phosphate. All you've done is to rearrange it, and the enzyme that makes this happen is called phosphoglucose isomerase enzyme. All right, so that's reaction 1 and 2. And then for reaction 3, here, a little bit, you're going to add another phosphate group to it. So here, we take fructose, still as we were before, and now we add a phosphate group to the number 1 carbon, and there's already 1 on the number 6 carbon here. So now this is called your fructose 1,6 biphosphate. That's reaction 3. And that's done by an enzyme called phosphofructokinase. So phosphofructokinase converts fructose 6-phosphate into fructose 1,6-biphosphate, and here again, this extra P comes from ATP. So ATP is brought in, broken down into ADP plus PI, and PI goes here. Okay, so that's reaction 3. Then let's do reaction 4. So I'm going to erase this. Okay, look at it. Take a picture of it if you need to, and let's move on. So start here again with your fructose 1,6-biphosphate. Fructose 1,6-biphosphate. Now we're going to split this molecule into three carbon molecule. Okay, so we're going to take it out here. One option, and we'll make two molecules. One molecule. Okay. It's a long line. We're going to space real quickly. So one molecule will be formed. Let's go back here. It's too far. Like so. Molecule will be called 3-phosphoglyceraldehyde. One up here as well. So like that. All right. Okay. So let's make this molecule first. Dihydroxyacetone phosphate. So you form it this way. So you have it's a 3-carbon molecule, 1 carbon there, 1 there, 1 there. The third one is attached to a phosphate group, like so. No, sorry, phosphate group, like so. Second one is attached to an oxygen, carbonyl group. And this is CH2OH. So this is called dihydroxyacetone phosphate. Okay. And the other one that you get from here will be formed this way. So you got there, there. Then you're bringing this to here. This like this. Okay. This one is called 3-phosphoglyceraldehyde. Okay, so that's reaction 4. And the enzyme that does this is called aldolase. That's reaction that makes reaction 4 go. That's the enzyme that makes reaction 4 go. And then for reaction 5, here the dihydroxyacetone phosphate will be converted into 3-phosphoglyceraldehyde. So this is reaction 5. Just converting this to this. So now you would have 2 of these, which means all the reactions going forward will happen twice. Once for each of the 3-phosphoglyceraldehyde. And the enzyme that makes this reaction take place is called isomerase enzyme. Okay. Then reaction 6, we're going to take this molecule and add to it another phosphate. So here we go. So taking 3-p-gal, bring it down to here, reaction 6. And here, I'm going to have again, here's a phosphate there. And here, add a phosphate group to this one as well. To the number 1 carbon. So now this is called 1, 3 means on 1 and 3 by phosphoglycerate. 1, 3 by phosphoglycerate. That's reaction 6. Okay. And the enzyme that does this is called dehydrogenase enzyme. And in this one, this extra P here, right? This extra P came from the cytosol. By the way, glycolysis takes place in the cell's cytosol. So you always have free phosphates hanging around. I mean inorganic phosphate hangs around in the cytosol, and so it's just brought in to attach there. And also at the same time here, we have another reaction, another critical reaction that takes place here where, another color, a molecule called NAD+ comes in and collects 2 hydrogen atoms from the reaction to form NADH plus H plus. So that also takes place in reaction 6. Critical things, okay? All right, so we've gone through reaction 6. Let's continue from here, okay? Erase this part. Should I walk it around as a circle maybe? So from 1,3 biphosphoglycerate, you then bring it back to reaction 7. Okay. And in reaction 7, you're going to remove that phosphate group from there. Okay. And so now, again, you're back to here. So you remove the phosphate group. So this is still on number 3. And then the phosphate group is removed, right? And replaced by OH. Okay. So now this is called 3-phosphoglycerate. And in this reaction 7, the phosphate group that's taken away from here is used to form ATP. So here, ADP comes in, picks up the PI from here to form ATP. And the enzyme that does reaction 7 is called phosphoglycerate kinase. So phosphoglycerate kinase is responsible for converting 1,3 biphosphoglycerate into 3-phosphoglycerate. Okay? And then from here, reaction 8. Go over some more. Now we're going to move the phosphate from number 3 down to number 2. Okay, so we're going to make it like this. Move it down to number 2. And then this by the way, this can be written as a COOH. So let's do it that way. COOH, okay, right there. And this now is called 2-phosphoglycerate, okay? That's reaction 8, where you've just moved the phosphate over, okay? And in this reaction, the enzyme that causes this reaction to go is called phosphoglyceromutase. That's reaction 8. Keep going. And then reaction 9. For reaction 9, here you'll convert this thing, convert that to another molecule called phosphoenol pyruvate. That's reaction 9. And here the molecules like this. So you have a CH3 H2, bam, bam, there. Still the phosphate is there, and here. Okay. So that's called phosphoenol pyruvate. And that reaction is triggered by an enzyme called enolase. Okay, it's reaction 9. And then in reaction 10, here you're going to remove that phosphate group, and then you'll be left with a molecule called pyruvate. So now you're left with this CH3, C there. Okay. This is called pyruvate. Okay, and the phosphate that was here is now again used to form an ATP. Okay, and that enzyme that does this one is called pyruvate kinase. So those are your 10 reactions of glycolysis. Know each step, know the enzymes, know their order, and keep track of the ATPs. So you form ATP in 2 reactions. Here, reaction 7 and reaction 10. And you consume ATP in reactions 1 and reaction 3. All right, so keep that in mind. I may even ask you at some point to provide to me a drawing of this step showing each of these chemical structures along the way. Okay, we'll pause there.